Okay, in section 4.4, we just assigned a few problems trying to review GCF and least common multiple. I just don't want to spend a lot of time on it because you've done it in previous grades. Um, we're supposed to first find the greatest common factor. Okay. With both of these things, sometimes you can look at them and see what it is, and then sometimes you can't, okay? So one of the things that helps if you can't just see it right off the bat is to prime factor. And if you remember, you can draw a factor tree, like I'll just come over here, 48. I know that is 6 times 8, right? And then 6 is 2 times 3, and 8 is 2 times 4. But 4 is 2 times 2. So I have 1, 2, 3, 4 2's. 2, 3, 4. And I have a 3, if I'm looking at all my prime numbers. Okay. Now what about 108? Maybe I don't know much about 108, but let's say I can see that 2 goes into there, and that would be, what, 54. And then I say, oh, 9 times 6 is 54, and 9 is 3 and 3. Oh, there's some prime numbers right there. And 6 is 2 and 3, okay? So if I look at that, I've got 2 2's and 3 3's. 1, 2, 2 2's and 3 3's, okay? So I can prime factor first. Now the greatest common factor is going to be, what I do to find it is to take each factor there the least amount of times that it occurs in both of the least amount it occurs, okay? Each factor. So for instance, 2. I'll do this part in red. I see 2 2's here. There's 4 up there, but they both have at least 2. So I know my greatest common factor is going to have 2 2's in it. And now I go looking at the 3's. There's 1 3 here. There's 3 down here, but what do they have in common? Just 1 3. Because, even though the bottom one has 2 extra 3's, I can't get that out of the top one, right? So that would be 1 3. So 2 times 2 is 4 times 3 is 12. The GCF is 12. That's the largest number that divides into both of them. Okay, in case you've forgotten that. Probably knew how to do it way back in the day and you've forgotten, maybe, if you're having trouble. All right, so now the least common multiple. The least common multiple is each prime factor that's up there the most time it occurs, because both of these numbers have got to divide into it, okay? So I've got to take each factor the most number of times it occurs, each prime factor. I'll look up here, there's 4 2's in the first one and there's 2 in the second one. What's the most number of times it occurs? 4 times, so I'm going to have 4 2's. Because if you think about it, what we're saying is we're trying to find a number that both divide into. And if I don't pick the 4 2's in this case, my 48 might not divide into the number I pick. Okay, so this can be kind of hard to remember the terminology, but hopefully it's coming back to you. Okay, so I also know I have some 3's, and the most number of time I see 3's is 3 3's down on that second factor. There's 1 up here, but I need to make sure I can divide 3 3's in it so both numbers divide into it. All right. Now, 2 times 2 is 4 times 2 is 8 times 2 is 16, and 16 times 3 is 48. Okay, I got this far. Now 3 times 3 is 9. I'm going to have to multiply some stuff out, so I'm just going to go ahead and say 3 times 3 is 9 and multiply it by what I had so far. 9 times 8 is 72. Put on your 2, carry your 7. 9 times 4 is 36. 36, and 7 is 43, so my LCM is 432. Okay, now I'm going to quickly factor as many of these as I can. I will start with number 1. We're doing 1 through 15 odd, and if you have trouble, hopefully you just watch the ones you have trouble with. 16x cubed minus 64x squared. Okay, the first thing I need to do is look for a GCF. Every single time, is there a GCF? Something divides out of both of these. Yes, 16 goes into both of these. Let me write that where you can read it. 16 goes into both of these, and both of these have an x squared. And so if I take 16x squared out of 16x cubed, I have an x left over. Then I write down my subtraction sign. 64 divided by 16 is 4, and I had an x squared, but I took it out. So then this is factor, and that's all you have to do there, okay? Now for 3, t squared plus 18t plus 81, you're thinking, what two things multiply to give me 81 and add to give me 18? And remember, if you have to, and I hope you're getting away from this because I'm hoping you're getting better at it, you're trying to multiply to find the number on the end, which is 18. Again, this is just when we have a Plano variable squared, no number in front of it. I'm sorry, we're trying to multiply to get the number on the end, which is 81. Let me put it over here since I messed it up. And then we're trying to add to get the number in the middle. So when you're multiplying, you're trying to get the c. If you think of this as ax squared plus bx plus c, you're trying to add to get the b, the number in the middle, if it's just a plain old t squared and not a 4t squared, for example. All right, well, we can see what works are 9 and 9. 9 times 9 is 81. 9 plus 9 is 18. So it would be t plus 9, t plus 9. Okay, go to the next one. The next one is, if you look at it, you say, okay, is there anything that divides out of both terms? No, kind of hard when you got a 1 there. But there's two terms and there's a subtraction sign. So what you should look for is this a difference of two squares pattern? Is 16k, so if it is, I'll say, well, what do you square to get 16k squared? Well, to get 16, I square 4, and to get k squared, I square k. So I'd write a 4k there and a 4k there. What do I square to get 1? Well, 1. So I write a 1 there and a 1 there. Since there's two terms and a subtraction sign, this factoring pattern is I write those things that you square to get those terms, then I need 1 plus and 1 minus. Okay, number 7, 4y squared plus 20y plus 25. Now, I want you to notice something about your first and your last terms. They're perfect squares. I could do this the long, hard way, or I can start looking for this pattern, and that's what I'm going to expect you to do, because if you see the pattern, it's not going to take you long to do this, but if you don't see the pattern, it's going to take you a long time to factor this. This right here, first of all, is there anything divides out of all those three terms? No, no number. The last term doesn't have a y, so no y comes out. But notice something. The first term and the last term are perfect squares. What do you square to get 4y? You square 2y. What do you square to get 25? You square 5. Now take those two things and multiply them together. 2y times 5 is 10y, right? Well, if I double 10y, do I get the middle term? Yes, I do. It's 20y. So what this pattern is it's a perfect square trinomial. Three terms, but it's a perfect square. It's not a difference of two squares. Don't get those two things mixed up. And since it worked out, and this middle term worked out by just multiplying the two things we squared together and then doubling it, all this is 2y plus 5 squared, which you could have written out as 2y plus 5 times 2y plus 5. Okay, number 9, 16x squared minus 25. There's no GCF. That's a difference of two squares. When you see two terms and a subtraction sign, that should be what you're looking to see if it works. Okay, so what do you square to get these two terms? What do I square to get 16? 4. What do I square to get x squared? X. What do I square to get 25? 5. So it's 4x and 5. 4x and 5, and on one of them I need a plus, on the other one I need a subtraction sign. Number 11, 121s squared minus 66st plus 9t squared. There's a long, hard way to do this one, and then there's an easy way. And we're going to try to learn the easy way. If you look, these first and last numbers are squares, okay? What do you square to get 121? You square 11. And what do you square to get s squared? You square s. Now look at the last term. What do you square to get 9? You squared 3. What do you square to get t squared? You squared t. Now, one thing I got to kind of notice here. This is a positive, but look here, there's a negative. So if this is going to work, this is going to have to be a negative 3t squared, because a negative squared is still a positive 9t squared. I got to somehow account for that negative sign in the middle. So if this is a perfect square, and it is, how you know for sure that it is you take this 11s and this minus 3t and you multiply them together. 11s times minus 3t would be negative 33st. And then you double it. And if you get the term in the middle, when you double it, you know you got a perfect square. Oh, I did. It's right there, isn't it? Okay? So this means this is 11s minus 3t squared. Okay, so number 13, 36p squared minus 49q squared. Is there anything divides out of 36 and 49? No. So no GCF. I see that I've got two terms and a subtraction sign. Are these two things perfect squares? Yes, they are, because I can square 6p to get that first term, and to get the 49q squared, I could square 7q. So this ends up being 6p plus 7q, 6p minus 7q. Okay. And we'll try to cram 15 here. 15 is st squared minus s. Okay. If you look at this one, you could factor out a s, right? And when you do, you get 2t squared minus 1. Well, if you look in the parentheses, you always need to check the parentheses to see if you can keep going. And you can. T squared minus 1 is t minus 1, t plus 1. It's a difference of two squares, and so you got to do that. And I'm going to do number 17. Let's see, it is t cubed minus 27. Okay, now you think, is this a difference of two cubes? Yes, it is. This is t cubed minus 3 cubed. Okay, so when you factor it, you take that t and the 3, and you say, oh, it was a subtraction sign there, it'll be a subtraction sign there. Then your next factor, since that was a subtraction sign, I'm going to write a term, then I'm going to have a plus sign, and there's always a plus sign down between the last two terms. I kind of do that first just because I'm trying to remember the factoring pattern, and then just fill in the numbers. And what I do now is I take the first thing and I square it, so that's t squared would be t squared. I take the second term, the 3, and I square it. That would be 9. And then I multiply the two things together, 3 times t, and that's what goes right here. That's a different factoring pattern.